Hello everyone, today the question we're looking at is question number 10 of summer 19 paper 4-1. The question says a bridge rectifier contains 4 diodes. The output of the rectifier is connected to a resistor R as shown in figure 10.1. The variation with time t of the input EMF E to the rectifier is given by the equation E is equals to 15 cos 210t, where t is measured in seconds and E in volts. Now this equation, if you see, is similar to one standard equation, that is x is equals to x naught sine omega t. It can be sine, it can be cos, depending on the situation given to us. Now we can see x naught is the max value, and then you have sine, and then you have omega and t. So if we look at this equation, we can see that this is E naught, this is cos, this is omega, and then this is t. Having said that, you move on towards the A part, which says determine the maximum potential difference V max across resistor R, and they've given us this graph of V against T as well. Now going back to this equation again, we know V max is the same as V naught, and V naught is simply given to us here, which is 15, and so our answer is going to be 15 volts, and that is it for the A part. It's for 1 mark as well. Moving on towards this B part, that says the time interval to two significant figures between time t1 and t2. If you go back to the graph, you can see this is time t1, and then these waves occur between this time interval, and then it reaches t2, and we have to find out the time interval. If you go back to this equation here again, you can see we have omega here, and omega is equals to 2 pi f or 2 pi by t. Using that, we know omega is equals to 2 pi divided by the time period, and since we have to find the time period, the time interval, we know omega, that is 210, and then we have 2 into pi and t. When we put this in calculator, we get a value of 0.0299. So t is equals to 0.0299. Now this is the time period. What is capital T? Capital T is a time period, time taken for one complete wave. But do you see how many waves do we have between T1 and T2? We have this as one wave, and this as this two waves. So this is one wave, and this is two waves. We know the time period for just one wave, which is 0.0299, and so 0.0299 for this as well. And when you multiply, so all you have to do is you simply multiply this with 2, and when you multiply this with 2, the value you get is 0.0598. Since we have to write it in two significant figures, we will simply write 0.060 seconds, and this is it for the B part as well.